Hello everyone. In today's video, we are going to solve the question maximum score of a good subarray. So the question states that we have been given an array. So let's say we take up the example array uh, 1, 4, 3, 7, 4 and 5. The indexing is 0, 1, 2, 3, 4 and 5. So in this particular array we have provided we have been provided a k value. uh, in this case k equals to 3. So we need to include this kth element in our subarray, and we need to find the maximum possible score of a good subarray. What a good subarray means that the kth element must be included in our subarray. What this line suggests: I is less than equals to k and k is less than equals to j. So this implies that the kth element is always gonna be present in our subarray. So this is meant by this statement. And one thing, that we need to choose the minimum element from our subarray, and we need to maximize the product of the minimum of all and the length of the subarray. So j minus I plus 1 denotes the size of the subarray or the size of the window. So the brute force solution includes that we can generate all the subarrays and we can check whether our I and j are lying in this condition or not. In case I and j satisfy this, we can calculate the minimum element, and also we can calculate the overall maximum possible score. So this approach is gonna take big O of n square, which is of course going to fail since the constraint limits are quite high. So coming to the best optimal solution, I would be using greedy algorithm. So it is sure that we need to include this element, right? So one of my possible options, maximum product, max p, which I am denoting, is 7. Next time I have this and this one as my options. So greedily I can think of, okay, let's include 4. So by including 4, my length of the subarray increases to 2, and 4 into 2 is 8. So my possible answer becomes 8. Next time I'm having this and this as the option, so this is included. I'm having this and this as the option. So greedily I can think of, okay, let's include 5 because 5 is greater than this element 3, and the overall minimum is 4 here again. So 4 into 3, that is 12, and I have included this. This side gets exhausted, so no worries, I can move on to the left side. I can include this. So this one gives 3 times 4, since the minimum element is 4 and size of this subarray is minimum is 3 and size of the subarray is 4. So 3 times 4 is 12. Next I'm going to proceed here. Again, the overall minimum present here is 3. So I'm going to choose 3 here, and I have this length of the subarray equals to 5. So 3 into 5 is equals to 15, which is of course better than this. So I'll update my max product. While I come to 1, my overall minimum shrinks to 1, and the size of the subarray is equals to 6, but 6 into 1 is not greater than the current possible option, so I'm not going to update that. So at last I'm having this value. So this was the overall intuition, and now let's run through the code. First of all, I have stated the size of the array. I have the overall current minimum. I have the forward and the previous pointers. Initially, both are kept at k equals to 3023. Both are at this position. So I need to iterate till I exhaust the whole array, and this takes up order of n solution, which is definitely going to pass. And like for the left element is the previous element in case the indexes lie within the boundaries, and in case the left element, so for example comparing this and this, I'm going to say okay, let's include the right element. So I'll come to this, I'll increase the forward pointer, and I'll update the current minimum. At last I'm going to update my maximum product in case the current good subarray's product is good, is larger than the current maximum product. Thank you so much.